This lesson is about the slope of a line, and the slope describes the steepness of lines in the coordinate plane. So as you can see here, the slope is the ratio of the vertical change to the horizontal change. So we often refer to slope as rise over run. Keep in mind that we always do the rise first and then the run when we're talking about slope. So it's kind of opposite of how we plot points. So if we take a look over here at this example, we can see that the vertical change from one point to another goes up 3 units and to the right 2 units. And from this point here to the next point that I can identify, it's up 3 and right 2. So you will notice that a line has a slope that has the same vertical change to horizontal change between coordinates. Now I'm going to point something else out here. What if I chose the points here and here? Let's do the rise to the run there. So the vertical change to the horizontal change. So from this point here, I'm going to rise 6 spaces and run 4 spaces. So the vertical change is 6 and the horizontal change is 4. Now if we do that, we can simplify that fraction and that becomes the 3 over 2 that we already had. So we will always simplify our slope to be in lowest terms, but remember that does not mean to write it as a mixed number. The slope of the line we would say is 3 over 2. So let's take a look at these examples down below. It says, find the slope of each line below. So let's take a look at this one. So they have come up with points right here and here. So all we have to do is figure out the vertical change, the rise, compared to the horizontal change, the run. So if I draw that triangle in there, I'm going to rise 3 units. I'm going to rise 2 units, and then I'm going to run 3 units. So the rise was 2, and the run was 3. So the ratio of rise to run is 2 over 3. And that is the slope of the line. If you take a look at the next one, we're going to go from the points that they designated. So we're going to rise here, which is 3 units, and we are going to run, the horizontal change is 5 units. So the slope is 3 over 5. And finally, this last one is a little different because we don't really rise. We fall. So in order to show that we're falling, the vertical change goes down 1. So notice that I put a -1 for down 1, and I go to the right 4 units. So the vertical change is down 1, and the horizontal change is right 4, so the slope is -1 over 4. Now I'm going to come back to this first example, and I'm going to show you something else with that. So if I take a look at this point here, and I travel to this point here, my vertical change is actually -2, and my horizontal change is -3. So I'm going to do that with a different color here. So this change is down 2, and this change is left 3, and left would be considered negative. So the vertical change is -2, and the horizontal change is -3, and we should know by now that a negative divided by a negative is a positive. So that still is equivalent to 2/3. And that's what I have as my answer. I would not keep both negatives in my answer. Taking a look at the next one, I could say that I'm traveling from this one down 3 and left 5. Down 3 and left 5. So a -3 over a -5 still ends up to be the 3/5 that we had as the answer. And finally, at this last one here, I could start at this point and go up 1, but then I would have to go left 4. So that would be 1 over -4. So 1 over -4 is the same as -1 over 4. As long as there is one negative in our answer, those are equivalent. So I could put the negative sign in front of the entire fraction 1/4. I could put it in the numerator, or I could put it in the denominator. Now we're going to look at the bottom part of our notes, and I'm going to use these points, or I'm sorry, these lines that we had up front, up top here, to show what I'm talking about. So we got an answer that was positive here. So if you look here at a positive slope, the line slants upward from left to right. So starting at the left-hand side, if you go up from left to right, that's going to be a positive slope. So notice that this line goes up from left to right, and we got a positive slope. This one also goes up from left to right, so we ended up with an answer that was positive. This one, however, goes down from left to right. We always read a graph from left to right, just like we read words in the English language from left to right. So since this goes down, that has a negative slope. And if you look at this answer here, this answer for the slope is negative. So that means it goes down from left to right. Now, two situations that we don't have up here is that we could have a 0 slope, which means the slope goes straight the line goes straight across, and the slope is 0. So we have a horizontal line, and the slope is 0 for that. We could also have a vertical line. Now, when we have a vertical line, the slope is undefined. And the slope is undefined because if you think of the vertical change to the horizontal change, if I go up from this point to this point, let's say, I went up 3 units, but my horizontal change was 0. So if I had 3 as my vertical change over 0, which is the horizontal change, that's not possible because we can never divide by 0. So because that's not possible, we have an undefined slope. Now if you use the same idea over here, if we start at this point and go, let's say, to this point here. So my vertical change, I didn't go up or down at all, so that's a 0. And my horizontal change was about 4. And 0 divided by 4 is 0. So notice that we have the 0 slope. So I have a nice, fun song for you to sing. And it's not really a song, it's just a little phrase. And it says that horizontal has slope of 0. So we're going to be singing that in class sometime this week. So enjoy it. Horizontal has slope of 0.